Assalamualaikum. Welcome back to the Jammer programming tutorial. It's been a year since the last our video tutorial on YouTube, and now we are back with a brand new tutorial about creating a simple microservices using Quarkus, Kong, and Kafka. This is a beginner guide for those who must learn how to build simple microservices. The services for this tutorial REST API. We will be using Quarkus, fastboot, and lower hidden set size memory of the Java microservice framework. The backend will use an RDBMS PostgreSQL. The service will use a different schema and NoSQL database MongoDB. The message exchange between services we use Apache Kafka, an open-source distributed event streaming platform. The client, such as mobile apps, PWA, or web apps, will access these microservices through the Kong API gateway. Kong is also good for communicating between services because it has low latency. How this microservices works will look like this. We will create three services: student, lecture, and study service. The student and lecture service will be using PostgreSQL with a different schema. The study service will be using MongoDB. Three of them will be running on different ports. Each of them will have the Kafka consumer and producer. For example, if the student service produces a Kafka message, then the message will the same topic will be consumed by other services. All services will register to the Kong API gateway. At the end, the client-side, mobile or web apps will consume the API using one port. In the production, the client-side will use one domain or URL. Let's get started with the main step. Step number 1. Set up the required environment. This tutorial will require the following tools, frameworks, and libraries: GTK 17 or more, Quarkus CLI, Maven, Docker, IDE or text editor. We are using Visual Studio Code. Now let's starting with install GTK 17 or more. To install GTK 17 on Mac OS, we can use SD command. Let's type this command in the terminal to determine the required Java 17 version. For this moment, we will use Oracle Java 17, which is already installed in this Mac machine. If you want to install it, just type this command. Check the installed Java versions by typing this command. Next, install Quarkus CLI. To install Quarkus CLI using SD command, type this command. Check the Quarkus versions by typing this command. Now we have Quarkus 3.26.2 as default Quarkus CLI. Next, install Maven. To install Maven using SD command, type this command. Check the Maven version by typing this command. Now we have Maven 3.9.10 as the default Maven version. Next, install Docker. To install Docker, first download the Docker installer for Mac and drag and drop it to the applications to install the Docker desktop. Run the Docker desktop application, then log in using your Docker account. To install Docker CLI, type this command in the terminal. Check the running Docker daemon by typing this command. You will see an empty Docker container list. Next, add plugins to the IDE. We assume that you have installed VS Code on your machines. Start VS Code, then go to the extensions on the left toolbar. Search for these plugins, then install them. Step number 2. Create student service. To create the Quarkus service using CLI, go to your projects folder from the terminal and type this command: create a new projects folder. Create a new service called student service by typing this command. Go to the newly created Quarkus project. Open with VS Code by typing this command. There will be a resource called student resources. There will be a resource called student resource with a REST endpoint to get a string response. Run this REST app for the first time by typing this command. Access this REST endpoint by typing this curl command in another terminal tab. You will see a string response like this. There is also a generated test unit called student resources test. To rerun the test command, type this R key. As the previous diagram shows, the student service uses PostgreSQL for data store. We will use Panichi, Hibernate, ORM, and add those dependencies by typing this command. Next, create a models or entities folder and an entity file in that folder. Fill that file with these Java codes. Next, create a folder for repositories and a class file inside it. Next, create a DTOS folder, add DTOS Java files for request and response DTO. Open student request DTO Java, then fill this file with these Java codes. Open student responses DTO Java, then fill this file with these Java codes. Next, create a folder for services and a class file inside it. Add the application scope annotation before the class name, then inject the previously created student repository. Add a method to save a new student. Add methods to get list student, student by ID, and student by SIDN. Add a method to update a student by ID. Add methods to get list student, a student by ID, and a student by SIDN. Add this method to delete a student by ID. Don't forget to add these imports. As you see, there are some constant variables. For that, we must create a constant Java file in the utils folder. Edit this constants Java file, then fill it with these Java codes. Back to the student services Java, then add these lines of import. We will use Swagger OpenAPI to describe and document our REST API. To do so, install OpenAPI by typing this Quarkus command. Before implementing OpenAPI in our resources, we must define the OpenAPI specification OAS file to describe the request and response. Create a folder in the DTOS folder, then create this OAS file. Fill that file with these Java codes. Back to the studied resource Java, then replace the existing Java codes with this. Before running this service, we must configure the application's properties, then set the server, OpenAPI, and database, open the application properties, then add these lines of property codes. You can see that we are using PostgreSQL with database name student and the schema name student schema. For that, create a new database and schema. Now we can run this service in dev mode by typing this command. The Quarkus service will run like this if no error is found. In the browser, go to localhost 8081 API Q dev-ui extension. You will see this Quarkus dashboard page. We can choose the Swagger UI to test the endpoints that we have created previously. Now you can test the post, get, update, and delete students from this Swagger UI. Step number 3. Create lecture service. We will use the same method to create a lecture service. Back to the school app folder. Type this command to create a new Quarkus service. As you see, we also added some extensions that will be used for this service. They are PostgreSQL, Apache, and OpenAPI. Next, create a models or entities folder and an entity file in that folder. Fill that file with these Java codes. Next, create a folder for repositories and a class file inside it. Fill that file with these Java codes. Next, create a DTOS folder and DTOS Java files for request and response DTO. Open lecturer request DTO Java, then fill this file with these Java codes. Open lecturer response DTO Java, then fill this file with these Java codes. Next, create a folder for services and a class file inside it. Add the application scope annotation before the class name, then inject the previously created lecturer repository. Add a method to save a new lecturer. Add a method to update a lecturer by ID. Add methods to get list lecturer, a lecturer by ID, and lecturer by LIDN. Add this method to delete a lecturer by ID. Don't forget to add these imports. As you see, there are some constant variables. For that, we must create a constants Java file in the utils folder. Edit this constants Java file, then fill it with these Java codes. Back to the lecturer service Java, then add these lines of imports. Before implementing our API in our resources, we must define the OpenAPI specification OAS file to describe the request and response. Create a folder in the TOS folder, then create this OAS file. Fill that file with these Java codes. Back to the lecturer resources Java, then replace the existing Java codes with this. Before running this service, we must configure the application properties to set the server, OpenAPI, and database. Open the application properties, then add these lines of property codes. You can see that we are using PostgreSQL with the database name lecturer and the schema name lecturer schema. For that, create a new database and schema. Now we can run this service in dev mode by typing this command. The Quarkus service will run like this if no error is found. In the browser, go to http localhost 8082 API Q dev. You will see this Quarkus dashboard page. We can choose the Swagger UI to test the endpoints that we have created previously. Now you can test to post, get, update, and delete lecturers from this Swagger UI page. Step number 4. Create study service. This service differs from the previous two services because it uses MongoDB as a data store. Next, back to the school folder, then create a new Quarkus service. Go to the newly created Quarkus service folder. We will access student and lecturer services using the REST client library. For that, make a new client folder and client interfaces file. Open student client Java, then fill this file with this Java code. You can see that the file has study response DTO Java. For that, create the DTO folder inside the client folder to make the DTO file inside it. Then add these lines of Java codes. Also, we need the DTO for the lecturer client. Then create a new lecturer response DTO inside the same folder. Then fill this file with these Java codes. Next, open lecturer client, then fill this file with these Java codes. We will use the Apache repository pattern to access MongoDB. Next, create a model folder and model or entity pojo file. Then add these lines of pojo of the Apache entity. As you can see, we have included the list of students who joined the study. Add the student Java file, then fill that file with this pojo code. Next, create a new folder called repositories, a new file for study repository and student repository. Open student repository Java, then add these lines of Java codes. Open study repository Java, then add these lines of Java codes. Next, create a new services folder and file for study service. Then add these lines of Java codes. If we see this kind of error, this means we need to install Kafka for this service. There are so many static constants in that file. Create a new util folder and a new constants Java file. Add or replace that file with this. Back to the study service, then add this line of imports. Next, we need to create the study request DTO for request body to save study. Then add this file with these lines of Java code. Before implementing OpenAPI in our resources, we must define the OpenAPI specifications OAS file to describe the request and response. Create a new folder in the DTOS folder, then create this OAS file. Then add these lines of Java codes. Back to the study resources Java, then replace the existing Java codes with this. Before running this service, we must configure the application's properties to set the server, OpenAPI, and database. Open the application properties, then add these lines of property codes. Now we can run this service in dev mode by typing this command. The Quarkus service will run like this if no error is found. In the browser, go to http localhost 8083 API QDev. You will see this Quarkus dashboard page. We can choose the Swagger UI test the endpoints that we have created previously. Now you can test to post, get, update, and delete lecturers from this Swagger UI page. Step number 5. Run all services as Docker containers. Before building all services for Docker containers, we have to prepare the PostgreSQL and MongoDB Docker containers. On Mac OS, we need to run the Docker app to make it work with the terminal. Next, open the terminal and create a new folder, dbdocker under the school app folder. Create two Docker Compose configuration files. Open the MongoDB Docker Compose YML, then add these lines of YAML codes. Open the PostgreSQL Docker Compose YML, then add these lines of YAML codes. Create a new SQL file under the same folder. Then add these lines of SQL codes to create the required schemas. Before running those Docker containers, create a new Docker network by typing this command and make sure your Docker daemon is running. Next, run both Docker containers by typing these commands. You will see on your Docker desktop app the running containers. Next, modify the application properties of the student service to be like this. In the terminal, back to the students folder, then type these commands to build the Quarkus service. Next, build the Docker container by typing this command. Run the Docker container by typing this command. Next, modify the application properties of the lecturer service to be like this. In the terminal, back to the student folder, then type these commands to build the Quarkus service. Next, build the Docker container by typing this command. Run the Docker container by typing this command. Next, modify the application's properties of the study service to be like this. In the terminal, back to the student folder, then type this command to build the Quarkus service. Next, build the Docker container by typing this command. Run the Docker container by typing this command. Now all services running on different ports. Step number 6. Register all services to Kong. While all services run, we must run another PostgreSQL service on Docker for Kong Gateway. Type this command to create a new Docker network. Next, run the Kong PostgreSQL database by typing this command. Run another Docker command to create migration data for Kong PostgreSQL. Now, we can run the Kong and Kong admin GUI by typing this command. To ensure this Kong is running, type this command in the terminal. We can view services and routes using the Kong admin GUI by entering this URL in the browser. To create the services and routes, we will use the URL in the terminal. Type this command to create a new student service. To view a newly created service, type this command. To update an existing service, type this command. Add a route to the student service by typing this command. View the newly created route by typing this command. Now the student services are accessible through the Kong gateway. Next, type this command to create a new lecturer service. Add a route to the lecturer service by typing this command. Now the lecturer services are accessible through the Kong gateway. Before registering the study service in the Kong, update the application properties of the study service to match the REST client URL. Build the Docker and rerun the Docker container. Next, type this command to create a new study service. Add a route to the study service by typing this command. Now the study service is accessible through the Kong gateway. Step number 7. Add Kafka producer and consumer. The scenario for message exchange between services is that the study service produces a message and then the student and lecturer services consume it. Begin by creating a new entity on student and lecturer services to save messages consumed by Kafka. On student service, create a new Java file under the models folder. Then add these lines of Java codes. Next, create a new Java file under the repositories folder. Then add these lines of Java codes. Before consuming the Kafka messages, add these Kafka extensions by typing this command. Add these lines to the application properties file. Next, create a new folder under the student folder and add a new Java file. Open that file, then add this line of Java codes. You see, we need to create a DTO map from the Kafka message. Create a new DTO file under the DTOS folder. Then add these lines of Java codes. Do the same as the previous step for the lecturer service. Form XML will now have these dependencies. The application properties will have these lines. The model's study activity Java will look like this. The repositories study activity repository Java will look like this. The DTOS study activity payload Java will look like this. The consumer study activity consumer Java will look like this. Open the study service to create a Kafka message producer. Type these commands to install Kafka dependencies. Open application properties and then add these lines to the Kafka configuration. We will produce a Kafka message when creating a new study. Open the study service Java, then add this import. Add send message to Kafka, so the save study method look like this. Don't forget to add variables to the constants Java. In the terminal, back to the db-docker folder and create a new YAML file. Open the Kafka Docker Compose YML file and add these lines of YAML codes. Next, run this Kafka Docker Compose by typing this command. We need to update the Kafka connection for each service. Open and edit application properties in the student service. Update this line to be like this. Do the same for application properties in the lecturer service and study service. Build and run the Docker container for all services. Now we can test the Kafka by running the post-study endpoint to the study service. That is the comprehensive step-by-step tutorial on building microservices using Java, Quarkus, Kafka, PostgreSQL, MongoDB, Docker, and Kong API Gateway. You can get the full source code from our GitHub and the full tutorial text base on our website. You can see all of them in the description below. Thank you.